for the future of America. Now, future of America is not secure. It's not. I worry. We're fading. We're fading fast. We're fading. Check this out. You go around the world, there have been famous scientists in the past in all the countries. Any country that had an academic tradition, they've had famous academics, okay? At one point or another in the past. Go around the world, how do people honor their scientists? They put them on money. There you go. You put them on money so that everybody can see it, so that everybody is reminded of how important these people are. Everybody. We actually have a scientist on our money. Where's the fellow who just spoke? Where did he go? Did he leave? Did he have to leave? Where did he go? The fellow from The Guardian. Oh, way in the back. Okay. Do you remember who was on the £1 note? And not anymore, so it doesn't exist anymore. Do you remember who was once on it when it once did? That's okay, because you're a medical doctor. That's fine, I'll forgive you. It was Isaac Newton. And you don't put the famous scientist on bills that are uncommonly transferred. You do it on the common bills, okay? The £1 note was Isaac Newton. Isaac Newton. Einstein is there. I got a whole collection of this money. I only show you a sampling here. Einstein is in Israel, where all the folks are honored. We haven't honored any scientist. Yes, Ben Franklin is on the $100 bill. Yes, he was a scientist. But there's not a trace of that fact anywhere printed on that bill. There's not even so much as a key on a kite string, okay? He's there because he was a founding father, not because he was a scientist. Wouldn't it be kind of cool if Americans knew that Ben Franklin invented the lightning rod, that he had one of the most important treatises in electricity and magnetism in his day that was read world over? Wouldn't it be kind of interesting to know that he saved lives by putting lightning rods on homes and on churches? Wouldn't it be kind of interesting to know that he was criticized by some pastors for thwarting the will of God? You get hit by a lightning bolt, somebody up there does not like you. Ben Franklin says, carry this lightning rod, and all is well. More money. Look at that. We got Euler and Gauss and Faraday and Pascal, and there's your £1 note with Isaac Newton. So maybe you're just too young to remember when he was, that could be it. That could be it. And of course, Galileo up there in Italy. Let's zoom in on Gauss. The audacity of the Germans to put a mathematical distribution function on their money. Okay, look at this. The day we have a mathematical function on our money, then I know we've been saved. But until then, excuse me. Periodic table of elements. I love this thing, okay? You remember this mysterious chart of boxes that hung in your chemistry class. There it goes. Well, I've showed a couple of different ways. I have a really nifty PTE program where you can show the elements in all different ways. So here they're color-coded for melting point. Okay, that's kind of cool. So low melting point is light, and high melting point is darker red. And so you see the elements grouped together. You have wolfram here, tungsten, and osmium, iridium. Tungsten is used in incandescent light bulbs so that it doesn't melt, okay? So had Edison had access to this, he would have come up with tungsten immediately rather than having taken him all the time that he did in the trial and error of testing different ingredients. Carbon, by the way, has the highest melting point of all elements. So this is just a cool things you can do. You can also code them, well, which elements were known to the ancients. Everything blue there was known to the ancients. So no one is credited with having discovered them. They're familiar: carbon, sulfur, lead, tin, mercury, gold, etc. You can move forward in time Sorry. You can move forward in time. You can move backwards in time. And so you can look at the discovery year color-coded. And so I've knocked this to 1869. So everything in gray was not yet known. So no one had discovered the noble gases over on the right. They were unknown in 1869. So Darwin, Origin of Species, none of that was known. All the rest in yellow had been discovered. Fine. But here's what's the cool part. We can code these by country who discovered the element. And it's very telling. Take a look at that. Country who discovered the element. And you can rank them. United Kingdom leads the way. 24. Why? We got UK in the house. Okay. 24. Why? Because England invested in particle physics at the turn of the century. They were doing things that no other country knew to even do. And so those investments before the empire fell were fundamental to our understanding of atoms, of particles, all of the sort of the pre-quantum mechanics understanding of the behavior of matter are traceable to the United Kingdom. Just take a look at that. Sweden is second in the list, but for a really, for a reason that is, they slipped in on this list, and I'll tell you why in a moment. So this, Germany, France, and United States is down there, but look at where we show ourselves. Check this out. You come all the way down to the heavy elements, and there you go. Look at that. Right after uranium, Neptunium, plutonium. And so since we discovered them, we get to name them. So if you look down here, there's americium, there's berkelium, there's californium. We had the naming rights for these elements. And not only that, plutonium, discovered in 1931, 1 year after the cosmic object that shares its name was discovered, which is why it got that name. So Pluto became an element on false pretense, by the way. But so that plutonium became the fissionable substance in the second of our atomic bombs. So our government knew and understood the value of this enterprise for war, and hence these investments went through. So you get to name things if you invest in them, whatever was the driver, in this case, war. That's why physicists were so important to the 20th century, which is why the person of the century was Albert Einstein, a physicist. Let's figure out what happened with Sweden. Sweden, there's a little town in Sweden called Jitterby. Okay? Jitterby happens to have a cave that was very rich in undiscovered elements. And so they said, well, let's try to vary the word to try. So the Jitterby, so they discovered element number 39, they call it yttrium, named after Jitterby. But then they found another element a few years later. What do you call that? Well, it's ytterby, let's call that terbium. Okay? Then they found another element. How about erbium? Okay? And then they had ytterbium. Okay? Then they're like saying, all right, enough is enough. All right? So, but it was still discovered up there in Sweden. Where is Sweden? It's Scandinavia, so call it scandium. Okay, so all these elements came out of this one cave in Sweden. And so that upped their numbers higher than it would otherwise be. So these are just naming rights, where when you invest in society and culture, you get to name your products. Is there a cost to society if you don't? I think there is. Yes, there is. A bad cost. I spent a lot of time in school, not living in the same place long enough to be tracked by the jury duty people, or whatever is the agency that calls you for jury duty. I finally got called. It was walking distance from where I live. I live in Lower Manhattan. And so there I was, proud to serve. At the time, I was teaching at Princeton in the astrophysics department. In fact, a seminar on, in fact, the evaluation of evidence and what that meant. So I'm there, and you know, and they get to the Q&A part. Okay? Any lawyers in the house? What do you call it? The Q&A part has some other name that obscures it. What is it, sir? Voir dire. You could have just called it Q&A, but you didn't. Because you want people to think that what you're doing is complicated. You should take cues from the astrophysicists. What do we call spots on the sun? Sunspots, thank you, okay? What do we call big red stars? Red giants. Regions of space, you fall in, you don't come out, light does a black hole. Origin of space-time, Big Bang. We are simple people in astrophysics. The universe is complex enough. I'm not going to lay down a lexicon so you think what we're doing is more complex than it actually is. I had to get that off my chest, I'm sorry. The voir dire part. The lawyer asks me, I see you're an astrophysicist, what is that? And everybody's listening. I'm there eager to serve. And I say, well, you take the laws of physics as discovered on Earth, apply them to the cosmos. It's okay. And I say, it says here you teach at Princeton. What do you teach? I said, well, I teach a course on evaluation of evidence and the relative unreliability of eyewitness testimony. And I was out. I was on the street 5 minutes after that. They didn't want to hear that I understood how to evaluate evidence. I was gone until the second time. 3 years later, I said, okay, I'm not going to tell them about this class. So what happens? I go in there. I make it to like the top 15. They're taking it down to 12. I made the first cut. So we're all squeezed into the box, and there's like a couple of extra chairs next to it. And the defendant is there, sitting right there, with the lawyer and the judge. And I forgot what this part is called, sir. I don't know what it's called, but the judge reads the facts of the case. Maybe there's another French word for that. Okay. Once again, voir dire. All right. So I'm there. The judge reads the facts of the case. The defendant was found in Upper Manhattan in possession of 2,000 milligrams of cocaine. This is undeniable. We are trying him for the possession of those drugs. And I'm there, and by the way, there's like a maid, there's like a janitor. These are like regular people in the real world up there with me among the 15. And I listen, and the judge says, well, do you have any questions about the facts of the case? Do you understand them? As I've read them. I said, I got a question, sir. Why did you read the cocaine possession the way you did? He said, what do you mean? I said, you said he had 2,000 milligrams of cocaine. That's 2 grams. The milligram is 1,000 divided by the 1,000 is 2 grams. Less than the weight of a penny. Why, sir, did you say it just that way? And then he looked at it, oh, that's just because that's how it's written here. He didn't know what he was reading. He didn't understand what he was reading. And so there I am, and I said, because it sounds like you're making the possession sound worse than it actually was. I'm concerned about that. There I was, back out on the street again. Now, the fun part of that one was, I think I contaminated the entire jury. So, I have still yet to serve jury duty.